with their work. It's really good.
Hey everybody, so we're back here to answer your questions. So again, if you want to post specific questions, you can do it via the chat on the YouTube channel. We have Steve over here. He's managing the questions. He'll chime in every once in a while as you guys post them. Today we want to answer some of the questions that were already posted in advance. Really, there was one that we wanted to address, but we're really open to what you want to hear about, specifically related to the project. We know that this is a big project. It's for the rest of the course, and so there might be a lot of questions that you guys have. So please make sure to ask them.
Yeah, and don't be afraid to ask. And we know this project having, is occurring at a pretty difficult time for a lot of people. So we want to let you know our thoughts, our hearts, and our prayers are going out to those in Mexico as well as those that have been affected in the Caribbean and Puerto Rico and in some of the South U.S. of the Gulf Coast area for these hurricanes and these earthquakes that have been going on. We know it's kind of ironic, if you will, that this project is falling right at that time period, and we did not choose that intentionally. But it's very interesting that when we started thinking about this project of what we wanted to be able to tackle with it and what we think our students would be interested in, this was something that immediately came to our minds last year creating it. Was people get affected in their everyday life where all of a sudden your world just got turned upside down, and we need to have ways to be able to help those people in need. So that it's more than just engineering is about building a cool car and engineering is about living on Mars. Engineering can be about helping people that didn't know they need engineers. And so we hope that you take this opportunity to look at what's going on in the world, look at your family members that might be affected, ask them things that they need, because you'll find it's really interesting from how it changes your perspective from what you thought would be cool to design versus what is really functional to design. And you'll actually see in week 12, we did an interview with a student team here last year that built a rescue boat for victims who were suffering through hurricane flooding. And what was interesting about it was at first they thought we wanted to add all these bells and whistles and really cool details to it. But once they started asking people, what do you need in the time of a crisis, they realized we just need something simple, something very effective that can help us in getting away from floodwaters in a very timely manner. And so that's what they were able to build. So watch for that in week 12. I know this could be a difficult situation for a lot of people. So if you are affected by any of these natural disasters and you do want to get some of that ID verified refund back, we have a path for you to be able to do that as well if you're not able to continue on. But in the meantime, we want to discuss how difficult this project is and how many pieces there are to it, because it is big. So we'll start with our probably one question we have from the discussion board. Or someone posted about, it was, I think it was Jesus, posted about
the extent to which math is used.
How much math and science is necessary to be an engineer. And that really kind of depends on the level and the industry that you're actually going to be going into. So everyone goes through a lot of the calculus and a lot of the physics that we have to go through, the differential equations, just to get to the degree of engineering. How much you use it is going to be up to the industry that you're in. So if you're in some sort of like a research think tank kind of area where you are trying to break ground in the physical world, you are going to be doing a lot of that calculus and a lot of that mathematics. If you're going to be doing more of a systems level design, you're not going to be using it barely at all. So how much you use it is really going to depend on just where you end up going. I was a systems engineer in the defense industry. I didn't do any calculus the entire time I was there. So I kind of joke that I forgot all of it. I couldn't tell you the difference between a derivative and a differential anymore because I can't remember. But the fact that I know that I went through it and I learned it, it's kind of growing up into that perspective of, do I have to learn this versus how do I learn this? So we always like to take the approach at college that it's not about trying to just pump your brain with all kinds of information. It's teaching you how to teach yourself, how to learn this information. But it could be very technical. It could be more system and design level where you're just coming up with concepts and putting the big pieces together and you don't really care about the physics behind it.
Yeah, and adding on to that, I think we have to realize that math and science are really tools to help us solve problems. So you may be using programs to do the math or science for you, but understanding where they come from or interpreting the results, that's what engineers do a lot of. So when you think about those models that we talked about, and we're going to be continuing to talk about throughout the semester, these models are what allow us to do design without actually having to build things all the time. So as you're going through the disaster relief project, we've developed some of those math models for you, for instance. So we don't expect you to know the behind the scenes stuff. That's what we've developed for you. But we do expect you to be able to use those to make design decisions. So whether or not you know all the equations for designing an airplane is irrelevant. We've already made that simulation for you. We just expect that you're going to be able to use those simulations. So the same thing is true in industry. You have to learn some of the basic building block tools, but oftentimes they get solved in these computer programs, and you have to be able to interpret the results effectively. I don't know if you noticed that in your industry as well. But.
Definitely. I mean, you have to be able to make sure that a lot of times we're going to be using simulators, we're going to be using different programs, but sometimes you want to know that is this result actually right as well, and be able to double check what's going on. So having that background is always going to help, but it just makes you that much more competitive of an engineer if not only you can do the design process, but you understand the reality and the beginnings of how that answer gets there. So don't get overwhelmed with your math classes, and don't think you're going to be sitting in a cubicle doing calculus all day long for 40 hours a week. It's not going to be like that at all. But there are going to be some jobs where if you are creating a brand new type of electrical motor, you are going to be looking at the electromagnetics properties that are going to go along with that. Versus if you're just taking a motor and then being the guy that puts it into an airplane, then you're not going to care about how the motor was built. So there's all just a balance of what industry you're going to work in and how much technical detail they're going to need to have you be able to apply. But very rarely are you sitting there just physically doing calculus over and over. We're applying something that people already know to a reason. So even if you are building motors or something and you have to apply calculus, you know what the calculus is that you have to apply to it. You're not out there just trying to figure out a homework problem. It's like everyone around you kind of knows this is the theory behind it. How can we use this equation to help us to solve whatever this design is going to need? Excellent.
Yeah.
Cool.
Do we have any questions yet from?
No.
No.
So one of the things that was brought up quite a bit in some of the early question discussion boards is issues with Fusion 360. We tried to address those as we went along, but you do have the opportunity to use Fusion 360 in this project as well. So we want to make sure that anybody who's still having issues downloading gets that help. I think we've isolated the problem between the 30-day trial and the 3-year issue. In order to get the 3-year license, you do need to make sure to select the option that you are a student. So during the download and install process, there should be a dialog box where it says I'm a student. So whether or not you have a .edu email address, you should be able to select that option, and that should allow you to download the full version of Fusion 360.
And then we were hearing after people downloaded it, they were still getting warnings that this is just a 30-day free trial. And Steve, what did you say? There should be a red star somewhere on the screen.
Yeah, so at the top right of the screen where it says you have 30 days left for this trial, or however many days left, it should be highlighted blue. If you select that, there's a selection that says to sign up for the student or educator license. And once you select that, that's when your 3-year trial begins.
Okay, so if you couldn't hear Steve, because he's off the camera, when you have Fusion 360 open, if you're getting a blue dialog box up in the upper right that says you're on a 30-day free trial, click on that box, and inside of there should be an option for you to be able to select that you are a student and you want to have that student license, because we do have an agreement with Autodesk that all of our GFA students will be allowed to use this as the 3-year license. So if you're still having issues with it, please bring it up to us, because I need to be able to understand what the issue is, so I can respond more than just, I'm having issues, this doesn't have the functionality. I need to be able to understand what functionality we're missing, or if it's a trial date problem, so we can get our representatives to help you out with that. we don't want to ignore you. We want to help you with your problem. So sometimes it's just about getting the right information out from you so I can help you figure out what's the path forward technically through some of these logistics.
Yeah, so maybe we can talk a little bit more about the project itself and kind of what's the best way to get started. So the disaster relief project, I mean, Ali mentioned a lot of things. This is a real world problem. People experience disasters around the world every single year. There's a lot of them, and we've tried to highlight the numbers, relative numbers of how often those kinds of disasters occur in the project document itself. So as it recommended in the project documents, start with just picking a location that you might be interested in. Maybe this is a location near you. So maybe you would be within the affected area zone, so you understand the culture a little bit more. Or this could just be somewhere where you have an interest for whatever reason. But pick a location. That's usually the best way to get started. Once you do that, really evaluate what are the needs. So if you look at the different numbers of disasters, that might help you understand what kinds of disasters your airplane solution might be working towards. Once you understand that, then you can understand a little bit more about what your airplane actually has to do. And that's where we get back into those criteria and requirements. For this particular problem, there's a number of different things you should look at. So the project document probably has a lot of information about requirements specific to this particular project. But as you go through this, you may have some other minor requirements that are based on customer needs. In general, try and keep your requirements to as minimum as needed to fully define the problem. So you don't want to over-constrain yourself and limit the possible solutions. At the same time, you don't want to come up with something that absolutely wouldn't solve the problem at all. So you have to kind of balance that out as far as the requirements are concerned. Criteria are really where you need to understand your customer. What will your customer find valuable in this kind of solution? This could affect what you bring on the aircraft or the payload that you might include. It could affect how far it might have to fly, which affects your aircraft design. Everything kind of relates to one another, so use those simulators early and often to kind of help tease out some of those different ideas. But we will, I promise, walk you through the design process, so we're not going to leave you hanging. There's a lot of information up front, but don't feel like you have to understand everything at this point. Every single week from here on out, we're going to be just looking at a specific part or a subsystem, and we're going to be designing those kind of step by step. Once you've done it the first time, then you can iterate, right? So once you understand how to design a subsystem once, then as you go through and design other subsystems, you may want to go back and tweak what you've done in the past, but hopefully by then you have a better understanding of how that design works. So this is an iterative process, just like we talked about with the design process. We don't expect you to get it right the first time. You're going to have to do some testing. You're going to have to iterate through this multiple times. But ultimately, the cool thing about this is you will have designed an airplane from scratch that will hopefully solve a problem that is real.
Yeah, and we know the organization of just the web page alone can be a little bit confusing. So just to break it down, what you're going to look at. This week is all about defining your problem, figuring out where do you want to be located, which of these disasters do you want to help? Because I don't want someone to go in and say, well, I'm affected by hurricanes, so I want to make sure that I solve the hurricane problem. Because if you're picking that New Orleans location, there might be other disasters that you want to include in there, and you're getting a little emotional because of the time. And so maybe you want to have an aircraft that's got multiple options, that it can be used for hurricane during hurricane season, then it can be used for tornadoes during tornado season. And so you're able to actually have multiple functions to make it the best use of it. But the web page itself, so this week we're going to focus on figuring out that problem, figuring out what are the minimum requirements. What does it absolutely have to do? Don't add in extra things because you think that you want it to do this. You could always add in extra features in the design, and that's a plus, but it doesn't have to do the things that maybe you're thinking of. So look through a lot of our project documents, and here's how things are going to be organized. There's a module at the very bottom, if you go like back to the original course page where it lists out all the week's modules. There's going to be a module way at the bottom called Disaster Relief Project. In there, it's going to have all of the documentation of the overall assignment description and the rubrics that we're going to be working towards for your final project deliverable and the report for that. So you're going to be working on every week building a new part of this airplane and then adding that to your final report. So we want you to work on this all over time and continually be adding to this. So it's easier when you look ahead and read what's going to be in the entire final report so that you know week by week what it is that we're going to add in. Also in that area, in that unit of the webpage, are the disaster relief scenarios. So we're linking you out to that folder, and we want you to watch the 5 different scenarios. So we have the earthquake, the hurricane, the tornado, the wildfire, and the zombie apocalypse. Of course, we can't forget the zombie apocalypse. And so watch those videos that we came up with, some different scenarios and some different facts that we want you to consider as maybe options of new improvements and new innovations for your design. Also in there, you'll see our boss, who maybe you recognize as is our Dean of Fulton Engineering here, the Assistant Dean, Dr. Colafello. He explains to you that you're a company and you're going to be building certain pieces. Everyone else in your company might be building different things as well. We don't have the ability to pair you up with other people to see what they're going to build. So you can just assume that other people are working on different things. Like, I think we said one of them in our frequently asked questions was like the ability to hover. So if you want to make this aircraft magically be able to hover for some reason, we have other engineers doing that because that's a little difficult for our simulators to handle right now. But he then explained there are going to be a series of different subsystems you're going to work on. So while this week we're not really working on a subsystem because we're going to be working on the project management of coming up with a schedule of how we want to divide up our time, and then the overall problem to better understand our customer. Next week, we are going to start getting into the different modules. And so we'll start out by discovering what do we want to build at the interior? What's the material that we want to be able to have on board or have available space-wise for these different disasters? And then from there, we're going to start building the wings. So we'll be building different structural variations to be able to lift your plane different characteristics so that you can make sure if your plane is heavy enough, it's still able to get off the ground, and you have different flight times that go along with those structures. After that, we'll then be able to bring in some automation, and we'll be learning programming so that you can have some sort of an automated feature in your design that you'll be able to simulate through another platform that we're going to introduce to you there. And you'll be able to make your own circuitry and your own designs that have a purpose specific for your plane. And after that, then we get into the testing and the evaluation and the iteration. So every week there's going to be some new kind of a simulator that you'll see. So the simulator you're seeing in week 6, you're not going to understand it. And we don't really expect that you will understand it this week. This is just where we had to put it. We're going to put it right at the beginning, and you'll be coming back to this simulator every week. Once you start figuring out, I want to be holding 10 stretchers and 40 different oxygen tanks for firefighters in my plane, I can add that weight in and then go back to the week 6 simulator and adjust your payload to account for all of that weight. And you'll be able to then see how it changes your overall aerodynamic characteristics of your design. And then once we get into week 8, week 9, it adds more to it. So we'll constantly be going back to make sure you're meeting the minimum requirements of, what is it, the coefficient of lift has to be greater than?
So rate of climb. So there's a number of different requirements that are specified in the project document. Again, that's why you want to define those early on. And as Ali said, you're going to be using these simulators throughout the design process, so don't forget about them and bookmark them so you can find them easily. You don't want to lose track of them.
And then whenever you're using them, again, if you're having questions of why is this happening the way it's happening, or what am I supposed to see from these results, just post some questions up on the discussion boards. Everyone will help us and help you, and then we'll be able to jump in and help you as well to explain this, because we know the simulator can get overwhelming. And I don't want to lose you guys at the front because you're thinking, hey, they said it's not going to be very involved with math and science, and now I have to understand how to build a plane on this first week of this project. No, you don't have to understand how to build the plane. You have to understand what the plane is going to represent. And then that simulator will come into play over time to make sure it's technically feasible there.
Yeah, and on the discussion boards, especially some of the introductions, a lot of you guys said you were really interested in robotics and controls and those kinds of things. Well, Arduino programming, this automation stuff goes right along with that. So while we're applying it to a specific problem in this class, you can keep learning about it and continue and extending those topics on it and apply them to whatever you might want. That's why we really want you to also be updating your e-portfolios or your Weebly portfolios, because these are useful skills to apply to a variety of different projects. So even if in your Devils project, if you had an idea that you didn't really know how to solve quite yet, maybe we can give you some more skills and you can go back and try and solve it and maybe make a real difference in somebody's life.
Exactly. And this project was picked, I mean, specifically for the amount of content that's in there. It's going to give you a wide range of comprehension of all different types of engineering. So we hate the classes that go through and say, here's what mechanical engineering is, here's what's electrical engineering, here's what's civil engineering. It's so boring and nobody gets it. And so unless you're able to actually use it. And so while it sounds like, well, this isn't it all aerospace engineering? Not really. It's some mechanical engineering that we'll be doing when we're talking about the aerodynamics of the plane. There's going to be some civil engineering when we're talking about the actual structures and the deformity of wings that's going to be going on. There's going to be electrical and computer engineering when we get into the automation. And so we've got all different types of little flavors in here. So hopefully you can get a little bit better understanding as well of what it is that you're interested in. If you really hated the version of figuring out the structures, but you really love the automation, now at least we've helped figure out a direction that you want to go to. And then also being able to see you can apply it to anything. So everyone always has the main kind of bias that things like civil engineers are only going to be working on buildings. That's just not true. They work on every project everywhere because every project has a structure. It has something that, even if it's a cell phone, they're testing, can I drop it and make sure that it doesn't break? They're going to be fixing it with a civil engineer to make sure that it has the integrity of the structure. So any industry you want to work in, you can do it with any engineering degree. We just have to be able to see how every single aspect can be applied to different industries. So that's what we were hoping to show you with this project.
And especially pay attention to those day in the life videos, because we have a lot of different kinds of engineers represented there, and they're talking about the skills, how they're using the same skills that you're learning in this class.
Exactly. And okay, do you have something?
Do we?
I don't think we have any questions. I'm not even sure we have any viewers today. So let me kind of discuss a little bit about how this project is going to be different from Devils. Devils project, you had 2 deliverables that were graded by us if you're ID verified, self-assessed by yourself if you're not. And this is going to be very different. We want to give you the team experience, but we can't put you in teams because we've got 4,000 students, so that's impossible. But we wanted you to be able to see each other's work, to be able to help each other and give feedback. So this project is going to take use of our ability to do peer assessments, which means every week we're going to be doing what's called a project memo. And in that project memo, you'll be doing a couple of pages, very kind of basic, get to the point, very quick explanations of what it is that you've designed that week, whether it be the wing structure, the models, anything like that. And so whatever you come up with in that project memo, we want you to submit it by Friday, and it's going to be Friday at midnight Arizona time. So, and by midnight, I mean like the beginning of the morning of that day. So Friday hasn't even come yet. It's the beginning of Friday. We want you to have that submitted Friday at midnight to then give some of your partners and some of the team members in the class a chance to be able to review that. So you'll be submitting that, your first draft. It doesn't have to be great, but something that you can get down on paper because you've only had a couple of days to work on it from Monday. But a few days worth of work, submit it by Friday, and then your team members and everyone else in the class will have Friday, Saturday, and Sunday to be able to give you some feedback. And so they're going to do a bit of a peer assessment where they give you some feedback, some critiques, hopefully some positive comments on what's really working on your design, what's interesting, or hey, did you think of this kind of a thing? And did you make sure to consider these different kinds of users so that it's handicap accessible? I don't know, whatever the users are going to be, to help you get a better, well-rounded aspect and perception of how to build your design. Then when you are as a classmate of our class, you'll be assigned, I think it's 3 peer assessments that you'll go through, and you'll do 3 different students assessments. And you can look at them and give them some quick comments. That'd be great. Have that submitted by Monday at midnight. Is it Monday or is it Sunday? I think it's Monday at midnight again, which is like the end of the day on Sunday. So Sunday evening at midnight, we want you to submit your assessments back. In my personal opinion, please don't wait until Sunday night because we're waiting for your feedback. We want to see it. So if you could do it Friday and Saturday, then if I get your feedback back, I can make some changes and I can make some adjustments over the weekend before I have to turn in my official submission on Sunday night at midnight, Monday morning, Sunday night, Monday morning, to be able to submit my official project memo. When you submit your official project memo for your actual grade, it is going to be self-graded for all of our different project memos over the weeks. I believe there's 7 of them. So you will be able to then go through and see what everyone else graded you. So then you can grade yourself and see if you had any room for improvement there to do your own self-assessment for this class. The graded assignments, if you are ID verified, that we will still be grading are your e-portfolios, and then your final design at the end of the semester, we'll be looking over that. But from now on, we're going to be doing peer assessments so that you guys can get each other collaborating together and get some better feedback and much faster feedback than we can do for all of our different ID verified students. So we hope that this is going to be a really interesting, really collaborative way so that you don't have to use the discussion board and see if your post is out there and nobody answers. We can send it to 3 people, and then that's all you have to do is look at those 3 students' options and give them some honest feedback so that we can kind of start helping each other and all do our own part there.
Yeah, just remember, if you want good feedback, you also have to give good feedback. So be thinking about how you can help other people improve. It's a useful skill to evaluate somebody else's work. I mean, you're going to have to do it probably in industry at some point in time. And being able to give good constructive feedback will help them improve, but it also helps sharpen your thoughts on the problem itself. We're also hoping that your different perspectives will come into play as well. So if you look at the backgrounds of all the people in the class, there's a lot of different backgrounds, a lot of different interests. Maybe looking at the problem a slightly different way will help you create a better solution for your project.
And we've got a lot of people that are living through the situations, obviously, right now or have lived through them. So, you know, if you're really confused and you want some help, you could post a discussion board and say, has anyone really been affected by a wildfire, and can you explain what that situation is like so I know better of how I can adjust my design? And so then I'm sure we'll have a lot of stories come out that will be so much more helpful than us just what we see on the news, because maybe you're someone that's you know, like us in Phoenix, we never have anything here. So we can't sympathize as much as someone who's actually gone through it to understand what's going on there.
And if there's not a specific discussion board for that, feel free to use the weekly question discussion boards at the beginning of each week. Just remember that once the week is passed, we don't usually go back and check those. So always post in the current week, whichever one we're in.
Right. And I think we had a question about as we respond to your posts, are you guys actually automatically notified? And I believe the answer is no. You have to actually follow your own post. So if you post something and you want to make sure that you get an answer, you're notified when you get the answer, make sure you click the follow tab, and then it'll send you an email whenever one of us and our instructional staff actually gets back to you, or one of the other classmates gets back to you to have some responses there. So you don't always have to be checking online every few hours to see when we're awake and when we're working on it, because we're probably in different time zones for you. Excellent. So this week is all about project management. Project management is tough, and it is the most hated part of engineering. By far, everybody hates this, even more than writing, is planning. This is an important task to always do up front, and I can tell you as someone who's worked on many proposals in industry, it's a pain in the, it's a pain. It's a pain, okay? And so what we want to be able to get you accustomed to is being able to explain what you don't know. So you don't know what you have to build. We get it. You don't know what's going to be involved. I totally understand. But you're going to be responsible for making sure that you have the ability to know your own strengths, your own time restraints, and your own resources, so that the people who are making deals of your executives, your management, your college business majors, they think they're going to be the ones that get to wheel and deal and say, oh, if you want a new app that's going to be able to solve calculus, no problem, we can build that in 2 weeks. Then they come to you as the engineer, and the engineer says, what? I don't know how to build this in 2 weeks. I'm going to need a year to build this. And you have to be able to have that intuition to say, I know how long I work, I know how fast I work and how efficient I am, and here's what I predict it's going to be able to take me, so that the engineers have a little more control when they're doing these proposals for projects to be realistic. The worst thing you can do is always underestimate. And everyone will say, oh, I can do this in 6 months. And 3 years later, the project still isn't done. And that's how things get over budget. That's how companies get in trouble for it. So we want to give you guys these skills early. What's really hard about it is you don't know what you don't know. So my advice is start with things like the syllabus, the assignment schedule. Work yourself backwards. So put in all the due dates of the assignments and let's start there, because the assignments will at least tell us what it is we're kind of doing, but at least give us a time frame of when it's going to be done. Then I'd start looking at, can I actually look at these assignments ahead of time? Some of them you can, like I believe I don't know if the report, if we put it in the disaster relief area,
Yeah,
I think we did. So you can look at the report, which is due like in week 15. You can look at it way early and start seeing what is going to be involved in there. And is there going to be CAD drawings? Is there going to be just hand drawings? Is there going to be different programs I have to write? And so then you can start building that into your schedule as well. So that if I know I have a report due December 4th, let's say, in week 15, I know that I should probably start working on it 4 weeks, 5 weeks, maybe 6 weeks beforehand, or as I learn something, I give myself time to put it in the report. And so this way you can kind of back yourself out by just working from the schedule that says, this is how much time I have. I now need to start filling in the holes. And then you can start adding in even the really small tasks of, when are you going to start doing a content mastery? Do you want to do it immediately on the day that you watch all the videos? Do you want to wait until the end of the week after you do the assignments? And start adding in all the other assignments that kind of don't have to do with the project, but they still take your time away from you, away from your families, away from your jobs, your kids. You have to make sure to plan for that, because this project is a lot more than just learn CAD and make your model today. It's going to be go back and forth. And so every week we have to make sure we give ourselves time to now take what I've learned and apply it to what I already did, so I can make that iteration. So as we kind of leave out time for do this assignment, now I have to leave out time for do the peer assessment, do the update, make sure I leave time to reiterate, and now you can see your week just got packed, even though it looks like you had one assignment. You have to do all of these other steps in between.
And don't forget to do them. As we're going along, we're trying to help you prepare for the final report. So every step along the way, every week is going to have stuff that's going to be going into your final report. So even if it's not necessarily due, so we have things called project work, and it says project work in the schedule. Do those at that time. One, the topics are fresh in your mind, but two, you will be using those in your final report. So if you do them now, it's going to make your life a lot easier.
And it's kind of, we've scheduled and allocated them in those weeks so that we know if there's going to be project work this week, there's got to be some lighter material going on as well, so that you are recognizing, okay, if they're asking me to do something, even though I'm not turning it in, it must mean I'm turning it in later. Let's do it now, because the next week's going to be even busier. So the best kind of practice is start with what we know. We know when the class ends. We know when the assignments are due. Those are our milestones. And then take apart every assignment. The most laziest schedules that we get turned in from our students is they'll take our schedules of our syllabus and they just put the dates on there. And they put every assignment and then just the dates. And they say, well, that's the schedule, right? Well, yes, that's the schedule I gave you, and you just made it into a Gantt chart. I need you to do more with it. And that's where you take every assignment. You dissect it. And you say, how much time do I need to, if it's a presentation, to make the slides? How much time do I need to be able to practice the slides? How much time would I need to record the YouTube video if it was something like building the actual presentation? So that you don't get frustrated and at the end, figure out YouTube's not working, Weebly's not working, I don't know what to do. We've given ourselves enough time to actually spread it out.
Yeah, I'm actually teaching this right now in my on-site sections, looking at planning out their projects as well. And yeah, I can tell you what Ali's saying is true. You don't really understand planning until you create a plan that's not very good and it fails and you don't know how to recover from it. So these Gantt charts can help you track your progress. They can help you understand, what are those most important tasks that I can't fall behind on. And they just help you track your milestones and, walk you through the project overall. That's the purpose.
Exactly. It's just here to help eliminate the element of surprise. We are not here to trick you. We're not here to make this a ha-ha moment. It's we know your lives are busy, so use this to balance your school life and your everyday life as well. So that way, you know, if there's a Thanksgiving holiday coming up in America, I'm probably going to be out for 3 or 4 days. I need to get that out of my schedule and know that that week is much shorter for the assignments that I have to do. And so now you can start fitting in vacations and work schedules and kids and blah, 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 to be able to say, these are the days I can do the homework. These are the days I need to set aside for peer assessment, which means these are the days now I have to do my assignment, even though I usually wait till the weekend. We got to be able to step up our game and keep it consistent. So we like to make this course, that's why we dragged it out to 15 weeks, so that you have time to breathe. You have time to actually, be able to concentrate on what you're doing, but be able to apply what you're getting and get something from your team, give everyone a chance to look at it so that it's more beneficial instead of just go, 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 let's learn some math really fast.
Yeah. So how are we doing over there, Steve?
No questions yet?
So Steve, based on what you've been doing in the class, anything that we need to talk about?
So this is week 6. So that means that next week we will be starting week 7. So we have about 80 students enrolled.
Okay.
And we are only getting about half of the submissions. So
if you can't hear Steve's comment, he said, if you are ID verified, we're only getting about 50% of the ID verified students actually submitting. So your grade is kind of, it's cumulative. There's nothing big at the end that's going to save you. So you need to start submitting those assignments if you are ID verified, so that we can make sure we get you the grade that hopefully you were shooting for. If you're not ID verified, we still really want you to do the assignments, because this is the time where we're going to start sharing assignments with our peer assessment. So it's going to be much more helpful if you do assignment, and then when you submit it, you can get some people back, and we have a much bigger pool of diverse individuals to be able to help with this than just 20 kids who keep doing their homework assignments and we see the same 20 submissions. So we want to be able to give you guys some options as well.
Yeah, even if you're audit track, I mean, think about this. We are learning a lot of really interesting skills, and you're not going to have as many of those aha moments, those eye-opening experiences, unless you actually do the assignments and really hear back from other people. I mean, if you just kind of haphazardly run through the course, you don't have the advantage of really getting critiqued. You don't really have the opportunity to learn from mistakes, and that is an important part of learning. So do make sure to do the assignments and turn those in on time, so that way you can get some of those eye-opening experiences.
Right. And I think one of the things that, you probably heard from Raul in week 5, Stay in the Life, was communication is such a huge skill right now. And it is a skill that is drastically dropping because of our smartphones, because of our social media, that people rarely know how to just sit and have a conversation instead of offending each other, instead of being rude and being stubborn. We need to be able to look at something and say, here's what I like about it. Here's what I think you need to improve about it. Here's what I think is missing. And what did you mean by this? So that people have a way to be able to explain and defend what they were deciding, instead of being able to say, this sucks, I don't like it. You want to be able to be better than that. We need to be more professional. So communication is going to be huge. And that's one of the things we wanted to bring out as a skill that maybe you don't even realize you're learning, but online communication is just as important as face-to-face, to be able to explain what it is that your thoughts are on paper, since you can't use your words and be able to call someone and tell them what's going on. We want to make sure that we're being very professional, being very considerate, very genuine and authentic in our feedback that we give back to each other, to make sure that we're all helping each other. Because when you start working, it is a team. No matter where you work, unless you are your own startup company by yourself, you're working with other people. And we want to make sure that everybody has the same mentality going into it, that my opinion is not always right. I need help from other people just to be able to validate what it is I'm making decisions on, so I can feel better that everybody else is in agreement with what I'm doing, and this is going to be the best for the population. It's not just one against the world.
Yeah, I know when I was doing some interviews that these companies are worldwide now, and you're going to be working and getting emails and collaborating with people around the world. So being able to communicate effectively in an online environment is a new skill that engineers are needing to develop as we globalize our economy.
So we hope this week is eye-opening. We hope it's not too stressful, so don't get stressed out. We just want you to start coming up with lots of ideas, crazy ideas. You'll see in some of our FAQs, we even give some crazy answers to possible options for solutions for things. So take this week as an opportunity to do some research online, ask around with some people that are gone through some of these situations. Use our discussion boards because we've got a huge community of people that have just lived through quite an effort there, as well, to be able to figure out what's really important in here. But also we want to make sure that you are as challenged as you want to be. So you understand Fusion 360. If you want to be able to model something in Fusion 360, do it. If you're really frustrated with Fusion 360, that's okay. We have other options. You can always do stuff by hand. You can use other software programs as well. Once we start learning programming, I'll give you some basics, and then you'll have a requirement for that. But if you want to do even more of going above and beyond, absolutely. Challenge yourself. This is your project. And all you are doing is helping yourself make that portfolio even bigger of everything that you've got to offer now to future employers and to other team members that might be able to join with you later on in other classes.
Yeah, we had fun making this project. We hope that you have fun going through it. Try and pull out those key insights, those things that are transferable across projects, because ultimately coming out of this class, we want you to be able to imagine and design and engineer solutions to problems that you actually face or that people that you know actually face. So we want you to be able to not just do a project, but be able to apply the skills to new situations.
Absolutely. We're excited to see some of your portfolios and look through to see these Devils projects and these presentations. So hopefully you had fun with that. And you didn't make it an Evo project. Obviously, we're the Sun Devils. So that's why we call it the Devils project. But we hope that you are starting to look at things in a whole new way to be able to figure out how can I make something just a little bit easier in my life to be able to start tackling some of these bigger problems that our whole entire world and all society is going through. So thank you guys so much for a great Devils project, and let's get started on the next one. I'm excited for this one to start.
Definitely. We'll see you guys in class.
Use the discussion boards, please. We're here. We're human. We're here to help you.
Bye.
Bye.